Okay, we're going to start, guys. I hope you are all there. This is a nice question we're going to do. It's a questions on electronegativity, standard notation, number of protons. There are 2 questions in there. You can see one. We're going to calculate also the atomic mass or relative atomic mass for ion using the isotopes. And then we're going to this last question. We're going to see if we can solve the 2 questions. All right. So we'll begin with question 4, just in a second. Okay, so here we are. Let me move this chair out of the way, and we're going to start. This is an important topic, guys. It is have to do with periodic table kind of, okay? So, it's here with all the wind and things like that. Okay, so we're going to start. This question, I have to go here, you know that. This question said, some information for the substance ion and sulfide ions are given in the table below. And then you have a table which is ion on top and sulfide ion at the bottom. Guys, you need to remember the table of ions, which I have it right here, the table of ions. You can see sulfide is S2 minus, is this one. I'm going to mark there. That one is sulfide. All right, so it's S2 minus. This one is memory, it's coming from sulfur. If you go to the periodic table, okay? So that one is important to note. So sulfide ion, before we even move on, let's write the symbol here, which is S2 minus. Right, now, what is the meaning of the 2 minus? The 2 minus means that sulfide or sulfur gave 2 electrons away. So it became S2 minus because it took 2 electrons. It have 2 extra electrons. All right? Don't misunderstand that one. Sulfur took 2 electrons and it became S2 minus. All right? So let's begin with this one here. Number of protons. The number of protons is what we call atomic number of the element. And it's going to be letter Z. Z is the number of protons. Number of protons. And it's the atomic number. So it is quite simple. All you have to do is to go to your periodic table, which I'm going to show you in a second. There is the periodic table, and then those atomic numbers that you can see the number on top in this periodic table, so it's 1, 2, 3, and so on. That is the atomic number. And guys, that is what we call number of protons. So the first one is for ion, and you can see that ion will have a 26 number of protons. So for ion, we have here 26 protons. 26 protons. Ion, as you see it there, is neutral. Ion is neutral. All those elements, as they are in the periodic table, they are neutral. It means they have the same number of protons and electrons. In this case, the number of protons is 26, and note the following. This one stays the same. You cannot change the number of protons. Only the electrons are going to be transferred, or the atoms can lose or gain electrons. The number of protons stays the same. All right, so electrons is 26. As you can see, they are the same protons and electrons because the atom is neutral. If we go to neutrons, how do you calculate the number of neutrons? Well, for the number of neutrons, you need another symbol that we call A. A is for atomic mass. The atomic mass is also given in the periodic table. Guys, let me just show you. If you go to the periodic table, here you have something called approximate relative atomic mass. So to work for the atomic mass in this topic, you have to round off if it's not rounded. For instance, iron, which is the one we're working, is 56. that is the atomic mass. All right, now the atomic mass, which is A, is equal to Z, which is the number of protons, plus N, which is the number of neutrons. Remember, I'm going a little bit more. I'm not just answering the question. This one is neutrons. All right. So if you have the atomic mass, which you get in the periodic table, and you have the number of protons, which you get in the periodic table, you may calculate the number of neutrons. So if you come here, neutrons is equal to atomic mass minus the number of protons. For ion, that is going to be equal to 26 minus the atomic mass. You go to the periodic table. I don't remember. Let's check. Yes, I'll check now that one. Yes, I will give you the answer in a second. I'll give you the answer in the question. So here, for ion, we have 56. That is 56 is the atomic mass. All right. So it's 56. I'll answer you just in a minute. Eh? It's 56 minus 26. How much is that, guys? That is 30. So we have here 30 neutrons. I hope that is clear. Now, the question is why number of protons and electrons are the same. Guys, if the atoms are neutral, as I did right there, neutral atoms. Okay, neutral atoms, let's write it down here. It's a good question. Atoms, if they are neutral, the number of electrons is equal to the number of protons. All the atoms, as they are in the periodic table, they are neutral. All those atoms, as you see them in the periodic table, all of them will have the same number of protons and electrons. For instance, if we go to magnesium, which is element number 12, it has 12 protons as well as 12 electrons, because there is neutral. If you go to oxygen, it has 8 protons and 8 electrons. If we go to sulfur, which is the other one in this question, sulfur, it is a number 16. Are you with me? Number 16 there. It has 16 protons and 16 electrons. Now, sulfide, which is the case here, is not sulfur. This is not sulfur. This is sulfur after sulfur took electron from somewhere else. Somebody gave electrons to sulfur. All right? And then sulfur became something we call sulfide ions. Sulfide ions, it means it have 2 extra electrons. This means 2 extra electrons. Matilda, I hope it's clear the question. That is why the number of protons and electrons is the same. No, in sulfide ion, we're going here now. This is not the same case. Protons, we have 16. Let's go to the periodic table again. We have with sulfur, you can see, is 16 protons. But electrons is not 16 because it has 2 extra electrons. So the number of electrons for sulfide ions is 16 plus 2 is 18 electrons. You see? Is that clear? I hope it's clear. Let me just check. My helper there, it is clear? I hope it's that one clear, guys. All right, so let's continue then. Then let's continue there. Now, the next question is number of neutrons for sulfide ions. Number of neutrons for sulfide ions. Guys, it's the same way. Remember, the only thing that changes was the electrons, not the neutrons, not the protons. So for sulfide ions, same story. You come here for a neutron, it's given to you 16, but if you have to calculate neutron is equal to, for sulfur, is the question? Oh, for sulfur, you go here to the periodic table. I'm looking for it once more. Sulfur, the mass is 32, so it's 32 minus the number of protons, which is 16, and that is 16. You see? So that is now in terms of this question using the table. Now, there is something else I want to add that it could be asked, and it's related to AZ, which is the standard notation. Now, the standard notation is not the blocks that you see in the periodic table. We use a standard notation to represent atoms. Now, in this case, you're going to have the element. All right, you will have the atomic number at the bottom on the left side and the atomic mass on top. All right, so this is what we call standard notation, and it is important. Remember, A is for mass, Z is for protons. So if we come here, for instance, let's do it for both of them. If you go for iron, the standard notation for iron, I'm running out of colors, and you guys know I like colors. You have iron is the element, is Fe. The atomic number is the atomic of proton, which is 26, is at the bottom, and the atomic mass is on top, which is what we say is not here, 56. So it's 56 on top. This is what we call standard notation for iron. This have nothing to do with the block you see in the periodic table. Now, if you do it for sulfide ion, the symbol is S 2 minus. How many protons does sulfide have? It has 16. 16 is at the bottom. How many, or what is the mass of sulfide? 32 on top. This is not sulfur, it is sulfide ion. All right, it is sulfide ions. From here, if you get the notation, you can see that this one have 2 extra electrons. 2 extra electrons. There we go. So any question up until here? I think the first part of the question is done, guys. It is very difficult to be moving up and down regarding the question here. Let me see, the question is there. We're going to Aufbau diagram just in a moment. I think we answered the table. Now we're going to the Aufbau diagram, which is also very important. All right, we're going to Aufbau diagram. I want to see, or find out if everything is clear. Okay. Okay, what part? All right, it's fine, no problem. No problem. What part should I explain? The standard notation? I will explain again, it's not an issue. Okay, it's not understand the standard notation. This one is not part of the question, guys. Note, this is not being asked in the question. I edit. All right, so let's use any other atom. Let's not use those two. Let's do the standard notation for oxygen. All right. Let's go for oxygen. I think I can erase this part here. If it's not, let me see, is there any message inside? Okay, it's fine. Let's understand that part. Let's explain that part, guys. And there is problems with the connection. Are you guys there? Mm-hmm. Is a problem with the connection, seems like. Maybe it's the rain. Okay, let's see. Let's go back. Let's go back to explain. I assume that you don't understand the standard notation. Now I'm saying the standard notation is not part of the question. I went a little bit further from the question. Okay, so now let's go to standard notation. Okay, let me clean this side here. Let me clean this side there. Okay, clean this side. Don't worry, I'll explain as many times as you need. All right. So now let's go to see, for instance, oxygen. Now oxygen is there. That is O. I'm talking about oxygen atom. All right, now oxygen atoms can form an ion, which is called oxide. Oxide is O2 minus. They are not the same thing. This is oxygen atom. This is oxide. Oxide gain 2 electrons. So if we know 2 protons, for oxygen atoms is 16. Let me see. Or 8, I don't remember now. Oh my goodness. Periodic table. Here, oxygen is 8. There we go. Is 8 protons. Oxide also have 8 protons. Electrons, oxygen atom, which is neutral, has 8. But oxide, it have 2 extra electrons. So it will have 10 electrons. Are you with me there? Now, the standard, if we go to the mass, is 16. Both of them will have 16 grams per mole. All right. So the mass for both of them is 16. If you've been asked in the exam to draw or to represent the standard notation for oxygen, pardon, oxide, for oxygen is the symbol, for oxide is the symbol. For oxide, the symbol is O2 minus. Once more, 2 minus. Why? Because it have 2 extra electrons and became negative by a factor of 2. Oxygen. Now here at the bottom is Z, which is 16, and Z, which is 8, and on top is 16. For this one is the same, because at the bottom is the number of protons. That one does not change. It is 8, and then on top is 16. That is what we call standard notation. I hope that is now clear. Any message, Gilberto? Yes, about Mac. So, is it now clear? Yeah, I guess I received a message from one of the learners in WhatsApp. I guess there is network issues, guys, because of the weather. There is a network issue because of the weather. We can continue. We can stop. It's up to you. I'm happy. Emil is fine with you. Yes, it's clear. Yes. Right? Okay, so that was in terms of standard notation. Now, standard notation, remember, not in the question. Now we're going to do the about diagram. There's a problem with the network, I can see, guys. Yes, we continue. So now that was standard notation, not in the question. In the question, we are going to go to the Lewis dot diagram. There we go. The Lewis, not the Aufbau diagram. Now, the Aufbau diagram is for the electron configuration. The Aufbau diagram, guys, is going to be done for the first 20 elements only. So iron, for instance, you are not going to be asked to do it. We only do it for the first 20 elements. That is for the Aufbau diagram. Sulfide belongs to the first 20 elements. If you go there to the periodic table again, you can see that sulfur is number 16. So it is in the first 20. This one is for Aufbau diagram. So I'm going to explain for sulfur and I'm going to explain for sulfide. All right, let's do for sulfur and let's do for sulfide. Now, when you do the Aufbau diagram, you have to use the number of electrons. All right, and the SP notation, you need the number of electrons, the total number of electrons. So that's why it's very important. Let's go. Aufbau diagram. You need the number of electrons. So whenever you've been asked to do an Aufbau diagram, make sure you get the number of electrons. We supposed to do it in the question for sulfide, but we are going to do it for both. All right, so you get the idea. So now we have sulfur. Sulfur, it could be written with F or with PH. Let's write it with PH. Sulfur. Sulfide ion. Sulfur, the symbol is S. Sulfide ion is S, 2 minus, if I'm not mistaken. Yes, it's a 2 minus. All right, so there we are. What we need, the number of electrons. Number of electrons. For sulfur is 16 electrons. For sulfide is a 2, so it's 20 electrons. And now this is the part where you go to the energy levels. You always will start with energy level 1, orbital S. So energy level 1, orbital S. 1s, you do 1 circle. In each case, 1s, 1 circle. Then it's coming energy level 2, orbital S. So it's another circle. Every S is a circle or square. It's up to you. I guess circles are easier to make. So 2S, 1 circle. Then it's coming P. So it's 2P is 3 circles. 1, 2, and 3. There is 2P. There is 1, 2, 3 circles. This one is the Aufbau diagram, guys. All right? Is the message there? Sixteen electrons. 16 electrons for sulfur, 20 for sulfide. All right, let's see quickly. We're going to sulfur. Remember, I'm checking the messages. That's why I'm going up and down. If you go to sulfur, the neutral atom has 16. All right. But the ion, it has 20. That's why I say I'm going to do it for both. Sulfur, sulfide. I want to do it for both because I want you to understand both of them. And then everything is going to be fine. All right. Then you go to energy level 3. Sorry, guys. Right? 3, and then it's 1s. 3 is orbital s. This is S. Then it's 3p, and it's 1, 2, and 3. Every p is going to have 3 circles. Guys, you can go up until 4s. I don't have a space, so I'm going to leave it there because I don't need anyway. I don't need a more. Yes. Yes, guys. This is for sulfur. This is for sulfide. I am doing both. You are right. It's 20 for sulfide. I am doing both of them because I want you to understand both of them. All right. So this one here is for sulfur, which is 16. This one is for sulfide. This one is for S2 minus. All right. So saying that, now we have to represent 16 electrons here, 20 electrons here. All right. 16 electrons, 20 electrons. This one is sulfur. Sulfur is neutral. So let's represent the electron. Now there are certain rules to represent those electrons. You cannot just start drawing electrons, right? So electrons are going to be represented with a single half an arrow. If you want to draw an arrow, be my guest. For instance, one electron represents one single arrow. You always going to start for the lowest one, for 1s. And each circle can hold only 2 electrons. You cannot place more than 2. Yes, because this one is sulfide. It is sulfide. It gained 2 electrons. Oh man, what is wrong, guys? What is wrong? We have sulfur, we have sulfide. Sulfur have 16 electrons, which is the neutral atom. Neutral atom. We have sulfide ion, which is an ion. This one have 16, this one have 20. Why? Sorry, I didn't understand. What? Not 20, 18. Oh my goodness, 18. Thank you. Yes, 18. There we go, 18. It's plus 2 electrons. 16 plus 2 is 18, not 20. I don't know, my math is prep. Anyway, yes. Yes, yes. So now we're going to represent the electrons, right? So it is 1 and 2. You cannot go to the second energy level before the first one is full. Now you're going to the second energy level. 1, 2, 3, and 4. Now you're going to the second energy level, orbital P. And now you have to place 1 in each of the circles. So it's 1, 2, 3, 4, 5, 6, and 7. Then you go back. 8, 9, 10, 11, 12. And now you place 1 in each. 13, 14, 15, 16. Pointing down, it doesn't really matter. There is the above diagram for sulfur. All right, is that clear? Let me see. No, guys, don't stress. It is really simple. You don't need to stress. It is clear. Let's do it for this one. Let's do it for this one. It's not 20. I ate wrong. My calculator was wrong. It's 16 plus 2 is 18. 16 plus 2 is 18, not 20. All right. So now we have to represent 18 electrons in here. All right. So it is going to be 1, 2, 3, and 4. Now here, remember, 5, 6, 7, 8, 9, and 10. 11, 12. Now remember, 13, 14, 15, 16, 17, and 18. This one is sulfide. If you can see, it's stable. This here is stable. It is stable because energy levels are all full. This one have a problem there because it have a space. So this is unstable. All right, let me see. Is it clear now? Is that understood? So is it now clear? This is a bow diagram. Now, we're going to do the SP notation, also called spectroscopic notation. The SP notation. SP notation for both of them. Now, for the SP notation, okay, it was my mistake, yes. So for the SP notation, we are only going to use the levels as well as the orbitals. All right, so we're going to come for the SP notation and we say energy level 1, orbital S, 2 electrons, so to the power 2. For the second one, energy level 2, orbital S with 2 electrons. All right, energy level 2, orbital P with 2, 4, and 6 electrons. Energy level 3, orbital S, 2 electrons. Energy level 3, orbital P, 2, 3, and 4 electrons. That is what we call spectroscopic notation or SP notation. I hope it's now clear. This is the SP notation. In the exam, they can ask you, they are going to ask you either a bow diagram or SP notation, or both of them. All right, or both of them. That is why I'm doing it, both of them. Now here is the same. I guess this one you can do it now without much problem. So you come here and you say 1s2, 2s to the power 2, 2p to the power 6, 3s to the power 2, 3p to the power 6. You see, that is the SP notation. So either one is going to be asked in the exam. All right, and it's really simple. If you think this is complicated, then you can do this one first. You can do that one first. It's not a problem. It's quite simple. So this one is in terms of SP notation. Okay, Chidu, what you say? You don't understand the SP notation? Okay, you tell me if you need another example. I understand. Okay. If you do need another example, then is okay. All right. Some people need another example. So let's do another example. Guys, start to rain. If you cannot hear, please let me know. All right, because it's raining and the noise is disturbing. But you please let me know. Let's do another example. Okay. Let's do another example. Any example? For instance, let's go to the positive ions, guys. Let's go to the positive ions, you know? So I'm going to raise at this side as well as this side, and let's go to a positive ion. Now, note the following. Non-metals will form negative ions. Non-metals will form negative ions. Metals will form positive ions. So let's go, for instance, to magnesium. All right. Let's go to magnesium. The idea is for you to understand, so you make sure you are clear here. Let's go to magnesium. It's element number 12. It means it has 12 protons, 12 electrons. All right? So let's go to magnesium. And magnesium, Mg. Magnesium can form magnesium ion. Magnesium ion is Mg2 plus. Yes. You see? Yes, it's fine. All right. So let's go to see magnesium ion, guys. Okay? Because magnesium ion is a positive now. So a positive, do not get confused. it means it loses 2 electrons. So this one will have 2 electrons less than it's supposed to. So magnesium is number, I have forgot the number of magnesium I said. I said magnesium was number 12. There we go, 12. So how many electrons does magnesium have? 12. But this one don't have 12 because it gave 2 electrons away. So this one have 10. Do you understand? So if it's positive, you take electrons. If it's negative, you add electrons. All right, so 12. 12. Let's go to do the above and the SP notation. So above diagram is 1s, 2s, 2p, and 3s, 3p, 4s. So if we do it, it's going to be like this. You do not have to do all the circles. That is the total one. For this one, it's the same. 1s with 1 circle, 2s, 2p, and 3s, 3p, and 4s. There we go. So now we have to make sure we place the 12 electrons for this one, but 10 for this one. So look here. 1, 2, 3, 4, 5, 6, 7. Remember always first make them full. 7, 8, 9, 10, 11, 12. That is the above diagram for magnesium. What would the SP notation be? 1s to the power 2, 2s to the power 2, 2p to the power 2 for 6, 3s to the power 2. This one is the SP notation. Above diagram, SP notation. For the ion, for this ion, all right, for that ion, what we have? 10 electrons. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so the SP for magnesium ion is going to be 1s to the power 2, 2s to the power 2, 2p to the power 6, and that's it. Now, important, you don't have to draw everything. So this one can stay away. You don't need. That will stop there. For this one, you can stop here. Let me clean it. You see, that is the above diagram for magnesium ion, guys. And that's it. We are done with SP notation as well as above diagram. I hope you get clarity in this one now. All right. So is it now clear? I think it's quite clear now in terms of a above diagram. Okay? So now we can go to the next part of the question. Now, the next part of the question, which is here, say how many valence electrons that the sulfide ion have. Now, valence electron, if is a neutral atom, this morning I explained in terms of valence. You can use the Roman number. All right, if it's a neutral atom. Sulfide is not a neutral atom. So all we have to do, guys, is to come to sulfide, and we have to do it. I didn't remember that I'm going to need it, so I need to do sulfide ions again. Yes, that the no is, you understand? Matilda, did you understand? If you don't understand, guys, you stop me and I will continue. Now we need sulfide. Let me redo it for sulfide. It's really fast. It's really fast. So sulfide, we need, sulfide ion was 18. My mistake, remember, eh? So it's 1, let me just erase, clean this one. Think if there's any question, guys, before I do this one, eh? So sulfide ion is 1s, 2s, 2p, 3s, 3p. I don't remember if it ends there. Let me see. It is how many? 18. This one is for sulfide. Let me clean this one, don't you make a mistake. There we go. This one is for S, 2 minus. So we have 18. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now they ask you for the valence electron for sulfide ions. The valence electron is the number of electrons in the last energy level. The last energy level is energy level 3. This is the energy level. That is the energy level. This one is energy level 3. This one is energy level 2. This one is energy level 1. Are you with me? These are the energy level. The letters are orbitals. So what is the number of electrons, right, in energy level 3? 2, 4, 6, and 8. Is 8 electrons. So the question say, and let me just remove that periodic table, how many valence electrons does sulfide ions have? What is the valence electron for sulfide? 8. All right, that is not for sulfur, but for sulfide. The last energy level is not 3p. 3p is the orbital. So it's the 2, 4, 6, and 8. I hope that is clear in terms of energy level, guys. Just let me know. Now, Matilda is a learner not from Kimberley, guys. Matilda is a learner not from Kimberley. So don't worry about Matilda. Just focus on yourself. Okay. So now the question is, any problem with that last question I answered there? Any question from just there before we move on to the isotopes? Yes? No. Leave Matilda is a learner not from Kimberley, guys. It's not from us. Leave Matilda. Matilda is another learner. It's a wonderful learner not from Kimberley. You know, our learners don't join the stream. Okay, so now any question before I can move to isotopes? Any question before I can move to isotopes? Did you allow me to move to isotopes? Speak to me. Can I move to isotopes? Yes, sir. Thank you. Is that clear or not yet? Huh? So we go to move to isotopes. Waiting so I can do the calculation for isotopes, which is going to be in the exam. Guys, for sure, you will have to do some calculations on isotopes. All right. You will be asked to calculate the relative atomic mass using the isotopes and the abundance on nature. All right. So, fine. So we can move now here. Let's move to the next question, all right, which is the isotope. Now, the isotope question says, ions have 3 common isotopes as indicated. They are giving you the following isotopes. Let me just write it here. Fe50 is Fe54. I'm writing on the board. It's Fe56. And then is Fe57. All right. That is, the percentage is, I'm writing on the board, 5,8. I wrote 8,8. 5,8. 91,7. And then remaining that you don't know how much is it. All right. So that is what they gave you. You don't have this one here. Now let's speak about isotopes before we even start answering the question. All right, let's speak about isotopes real fast. Very, very real fast, like quickly. Now, these numbers that you see here, after the line, whatever is the name of that line, this is the mass of that specific isotope. That is another way of represent isotopes. All right, now if you move back to standard notation, which I explained, and that is why I explained before coming here. If you go to standard notation and you go to, for instance, ion, which is the situation here, you go to ion, remember, is 26 the number of protons. All right, so if we use the standard notation for ion, we have three different ones. We have ion 54 is Fe, 26 at the bottom, 54 on top, 54 on top. The second one is Fe, 26 at the bottom, 56 on top. And the last one is Fe, 26 at the bottom, because all of them are ion. So all of them will have 26 protons, which is the number at the bottom here. All right, so they are isotopes. They have the same number of protons. We're going to the definition just now. Now here, we don't have the percentage of this one. We'll need it. This one is 57 here. All right. These are isotopes. Now, what are isotopes? They have the same number of protons, different number of neutrons. That is why the mass is different. Or you can say same Z. What is Z? Atomic number. Different. What is A? Atomic mass. So this is in terms of the definition of the isotope. Isotopes can be represented using this way, or they can be represented using this way. All right. Now, this is the percentage. Like naturally, when you have ion, you have different types of ion, different isotopes. All right. We have ion of this one, which is the more abundant. So when ion form naturally, most of the time will be this one here. How do we calculate this one here? Guys, this is percentage. So the total must be 100. So how will you calculate that one? This one will be 100 minus 91,7 minus 5,8. When you calculate that one, do it for me, guys. Let me redo it also. Minus 91,7 minus 5,8. We get 2,5. So the percentage, guys, check my calculation, please. Check my calculation. I got 2,5. 2,5. Yeah, 2,5. I hope you got 2,5. Let me see. They say it's 2,5. All right. Okay. All right. Then. So it's fine. So this is in terms of isotopes. Now we have to calculate the relative atomic mass. How do you calculate the relative atomic mass? It's quite simple. It's really simple. If the mass multiplied by the percentage divided by 100, and you do it for each of them, you can do it separated, or you can do it in an equation if you want. It's entirely up to you. So for instance, you can say that it's 54 times 5,8 over 100. That is for the first one. For the second one, you got that is 56 times 91,7 over 100. And for the last one, you get that is 57 times 2,5 over 100. So let's do those calculations real fast. Let me see if I can do it. You can start there, make sure you can do it, guys. Let me see. This one is 54 times 5,8 over 100. I'm doing the question as it's 3, I get here 3,132. 3,132. For the next one, I get this one is 56. 56 times 91,7. This one gives me that is 51,352. And the last one, you do it, guys, so long. You can do it so long, please. It's 57 times 2,5. I'll get 1,425. Now, the relative mass is going to be the addition of all of them. So you get that it's 3,132 plus 51,352 plus 1,425, and I'll get that it's 55,909. Now, guys, this question, the best part is that you can always check your answer. You should get that answer in the periodic table. For iron, you can see it's 56, which is rounded off from here. It is correct. So that question is correct. You should get the same molecular mass that you get in the periodic table here. All right. So if you see, there is the periodic table for iron, 56. Guys, we are done with this question. Just want to know if there is any problem. Any question? Any problem here with this question? So we can move to the next question. I think it's taking too long. Took longer than I expected. Should we do the next question? Yes. I'm just going to show you in a minute. Come here so they can see you. Yeah. The other Gomez is the one that is helping me with the message. Here is the Gomez. He's helping me with the message there on the side. Okay, is Matilde still with us? I hope she didn't leave. You people are making the other children scared. All right, so guys, you tell me if we can go or we can. Okay, so we continue with the next question. We continue with the next question. It's fine. So the next question, guys, is not that bad. It's not that bad. I have to go quickly to the question. Let me show you the question, because there is few definitions that I also want to share with you. The question says the table below show the first and the second ionization energy of elements in period 2. So we are dealing with the second period. So let's focus here. Second period, it starts from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So we only dealing with that specific period. Okay? So now the question further state the following here. Explain why there is a general increase in the first ionization energy ongoing from left to right across the period. Now let's look at the definition of ionization energy. There is a definition. I did write it there so you can see it. Ionization energy is the energy needed per mole to remove an electron from an atom in the gaseous phase. Guys, it is very difficult to remove electrons from non-metals. When you come to the non-metals, towards the end there, all right, there is more difficult to remove electrons from that side. The attraction between the nucleus and the electron is stronger. In actual fact, those atoms towards the right side, from left to right, are smaller. Therefore, they are closer to the nucleus, and the attraction is a little bit difficult, or stronger. This one is the definition. I just want you to write it there. All right, so now here, let's continue. That one is in terms of ionization energy. Guys, the other definition that can be asked in the exam is electron affinity. Those are two different definitions. Make sure you look at them. If possible, write them down. You can go to the lesson because those two definitions are different. Both of the definitions, both of them, either electron affinity or ionization energy, increases from left to right within the period. For instance, as you move from lithium to fluorine to neon, the electron affinity as well as the ionization energy increases. All right, so that is very important to know. I just put the definitions there, guys, because I thought it's really important here. The next question, it is observed that the second ionization energy, now the second ionization energy is the one needed to remove the second electron, is considerably higher than beryllium. Explain that observation. Guys, because it's more difficult to remove two electrons. If you go to beryllium, if we go to beryllium, for instance, let me just explain in terms of beryllium and lithium, and you will see how easy it is going to be noticed here. Let me just go to the periodic table quickly. We go to lithium and beryllium, 3 and 4. All right, so 3 and 4. And we're going to do the Lewis dot diagram for both of them. You will see what is the problem here. Let me see. Now, what is the first ionization energy? Energy needed to remove the first electron. When we say the first electron, is the one that is in the last energy level. So it's not the one in 1s. We have lithium. Let me do it here. Let me dry because it is wet. This one is lithium. Is Li. We have 1s. How many electrons does lithium have? 3. 3 electrons. The other one is beryllium. Be, it has 4 electrons. All right. So this one is 1s. 1s. Then is 2s. Then is 2s for both of them. Let me make sure I am in the correct track here. Yes, it's 3 and 4. So it's 3 and 4. So look here. When we're referring to the first electron, it's 1, 2, and 3. 1, 2, 3, and 4. 1, 2, 3, and 4. Now, what is happening here? The first electron we're dealing with, or we are talking about, is this electron here. The first electron from the outside of the energy level. So it's not from the first electron is not coming from 1s. The first electron we're dealing with is the last electron that you can see the formation of the above diagram. Here, when we refer to the first electron, it's either one of these two. All right. So if you see, this one is more difficult than taking to this one in terms of the first ionization energy. But when you go to the second one, second ionization energy, if you go to here, then it's to take one of these two electrons that are extremely close to the nucleus. So the attraction between the nucleus and these electrons is very, very strong. They're very close to each other. But the second ionization energy from beryllium is going to be that one there, which is not as difficult. All right, so if you take the first ionization energy of lithium, lithium becomes stable. If you take one ionization energy of beryllium, it is unstable still because it has an extra one. All right, so that is the explanation. I hope you get it. It's a little bit tricky to understand, guys. I know it's a little bit tricky to understand, but it's not of a big issue there, really. It's not really a problem there. Okay, so let's go to the next question. This one is almost done. They say write down the name of the group whose elements have the highest phase ionization energy. Now, I spoke about that one already. All right, I spoke about that one already. I say in the periodic table, the ionization energy generally increase as you move to the right in the same period. So the group 18 will be the group that have the highest ionization energy. How do you call that group, guys? You call it noble gases. I don't think there is a need for me to write it. It is noble gases. You need to know the name of the group. Group 1 is alkali metals. Group 2 is, okay, I'll be there now back there. Group 2 is alkali earth metal. Group 17 is halogens, and group 18 is noble gases. They referring to the noble gases. Okay, Tandy, let's have a look here. Look here. When we're referring to the phase ionization energy, this one is not just for Tandy, but it's for everyone. When we refer to the phase ionization energy, we are referring to the to the last electrons actually of the electron configuration. For instance, if you go here, this one is the nucleus. For lithium, you have 1, 2, and 3, 1, 2, and 3. This is the nucleus. You have here 2 electrons. You have another energy level 3 with 1 electron. This here is the electron we are talking about. That is the first electron to remove. So when we speak about the phase ionization energy, is to remove that electron. In this case, you have 2 electrons. So if the nucleus is here, and then you have the 2 electrons, 1 and 2, and then in the next energy level, which is energy level 2, we have another 2, 1 and 2. So for clarity, remove the first energy level is to remove this one. This one is the first. In this case, the first is either one of the last energy level. So this one could be the first. The second will be this one, for example. But for lithium, the second is one of the electrons that is going to be very close to the nucleus. It's literally impossible to remove it. It is too close to the nucleus. So you cannot remove that specific electron there. In this case, you can, because it's still away, it's still in energy level 2. I hope, Tandy, that one give you clarity. That is why the second ionization energy for lithium is greater than beryllium, not the first ionization energy. All right, so we can just finish the question, guys. We can finish the question now. The rest is just writing formulas here and names. All right, the rest is writing formulas and names. Let me just clean this part of the board so I can use it. Move this shade that my son plays in the middle. Guys, is Matilde still with us or she left? I want to know if she's still with us. Okay, this question says write down the chemical formula of sodium oxide, calcium phosphate, and copper 2 carbonate. For this one, we need the table of ions, which I have here. This is the table of ions. We're looking for the first one was sodium oxide. So you come here, you look for sodium, which is a positive ion, and then you're looking for oxide, which is a negative ion. So let's go and do sodium oxide. All right, let's do sodium oxide, which is here. We have sodium oxide. Sodium is Na plus. It's coming from the table of ion. Oxide is O2 minus. All right, what is going to happen is the numbers are going to swap places. So this 2 is going to go there, and the 1 of the sodium is going to go there. So we are going to have Na2O. This is sodium oxide. Sodium oxide. I hope that one is clear. For the second one, they say, let me look, the second one is calcium phosphate. So when you look for phosphate, which is here, let me see if I find it. Phosphate, PO4 3 minus. So it's PO4 3 minus. And calcium is going to be, calcium is Ca2 plus. Ca2 plus. This is a good example. Let's see how to do that example real fast. All right, let's see that example. So I did right here the 2 ions, calcium 2 plus, phosphate. Now remember, the 3 plus is for everything. That 3 is for everything. All right, so this 3 is going to move to that side. That 2 is going to move to the outside here. All right, so we're going to have the following. Ca, the 3 of phosphate is going there. Now, phosphate is PO4, so it's PO4 bracket with the 2 that is coming from calcium. This one is calcium phosphate. I hope you get clear there. This question is also going to be in the exam. You have to memorize the table of ions. There is not other option here, guys. All right, let me see if there is any question. Okay. All right, Matilda, I'm really happy. Okay. No, you are not going to be given the table. You have to memorize the table. You have to memorize the table. We can look at the other one, the last one. Let me just look for it. It's going to be here. It's copper 2 carbonate. So once more, you go to the table. Carbonate is CO3 2 minus. So let me just clean this side. I'm going to show you in a second. Here. There we go. It's copper 2. You have copper 2 and you have copper 1. So you look for copper 2. Here is copper 2, guys. It's Cu2 plus. All right. That is copper 2. I'm going to write it here quickly. Cu2 plus. And carbonate, you can look for carbonate here. It's CO3 2 minus. CO3 2 minus. All right. So let's have a look to this one quickly. How to solve? Copper is copper 2 is Cu2 plus, carbonate is CO3 2 minus. The numbers swap places, so it's similar to calcium phosphate. So Cu will take the 2 from carbonate. So it it's going. Let's do it like this. Cu2 from carbonate, CO3 bracket 2. But if this one is a little bit like wet. Sorry, guys. Like wet, I'm struggling to write in there. So here we have Cu, there we go. 2 from carbonate, CO3 bracket 2 from copper. But if the numbers are the same as it is here, then it's like you simplifying that one. So those 2 fall away. We'll have Cu, CO3. That is copper 2 carbonate. I hope it's clear. Once more, let me look here. We're almost done with the question, guys. I'm sorry for the long stream. It was not my plan. Then we have to write the name is better. MgBr2, that is magnesium bromide. Magnesium bromide. You come to the table, you have Mg is magnesium, you look for it. Be careful with manganese. Magnesium is Mg. You can see it there. And the other one is Br2. So you have Br, not just Br2.
which is bromide. So it's magnesium bromide. And the last one is NH4. NH4 is the positive one, is ammonium. It's a very important ion you are going to be doing, which is there. Okay, is ammonium, and then let me quickly look here. Is ammonium sulfate, another very important ion. So it's the combination of ammonium and sulfate. Be careful with sulfate because you have, you see, you have sulfide, and you have sulfate. So ammonium sulfate is the last compound. Guys, this is the end. Finally, it took long. I hope you really understand. Now it's only questions. So I'm only going to ask if you have any question. First, I want to know if did it help? I want to find out if it did help, guys. The stream is a little bit longer than I expected. If it's the same number, you cannot leave it. So if the numbers are the same, you cannot keep them. Like for instance here, when you have 2 and 2, you cannot keep them there. You only keep them if they are different. But if there is the same number, you remove the number. All right, for instance, if you have magnesium oxide, is MgO. Remember, Mg is 2 plus, O is 2 minus. When those numbers swap, you will get Mg2O2. Those two fall apart and you will get MgO. You see? So if the numbers is the same, you take them away. So I'm just waiting for a question so we can finish. Well, we cover everything up until here. We still have to go to stoichiometric, which is a problematic topic. We have to go to other part, but maybe we can do it tomorrow, guys. Maybe we can do it tomorrow. So now I want to know if there is more questions before we finish. Anybody that needs, yes, it's fine. Anybody that needs something else, guys? Any other question before we finish the video? Yes, we can do tomorrow later in the afternoon, sometime in the afternoon. We can do the last 2 or 3 questions left for the question paper. Yes, I can send the table to you all. I can put a link to the group also, to the video, so you can get it. So if it's not question, guys, any more questions? No questions? All right, so we can finish now. But thank you, guys. I really hope it helped. If somebody didn't find it helpful, it's fine. It's not a problem. Not everyone understands, you know that. So just let me know anything. We're going to finish. Then tomorrow we can organize for some time in the afternoon. I have a couple of things to do in the morning. And then we can do it. You can come with questions as well. If you have any other question, we still have to go to, I don't remember what question we didn't do. This is question, what question we say? This is question 5. So it's 6 and 7, I think, which is stoichiometric, is very important and it could be problematic. So, you know, it could be problematic. But guys, I thank you all. And then I'll see you tomorrow. I'll see you tomorrow, guys. Thanks a lot.